Hello, and welcome to this presentation of the new HVLED series, a family of mains-operated LED lamp drivers from STMicroelectronics, the world leader in ICs for electronic lighting control. The HVLED will help you in the design of reliable and efficient ultra-compact LED lamps, ready for future-proof applications. The HVLED's PWM current mode controller with constant output current and voltage regulation provides an efficient, compact, and cost-effective solution to drive low and medium power systems, such as small control equipment and retrofit bulbs operating with a wide mains range. The HVLED can also be used to generate an isolated stable voltage or high-power factor flyback in a multi-stage conversion architecture. General lighting is a new application for LEDs, with large potential for growth. In 2016, LED replacement lamps are forecast to be the largest solid-state lighting segment, and are expected to account for 80% of the lighting market by 2020 or sooner. Market trends in lighting are driven by energy saving, aimed at protecting the environment, and reinforced by different national and international standards, such as Energy Star in the U.S. LED systems supplied from the AC mains exhibit the best option in terms of lumens per watt and costs. For example, a 3-watt LED lamp can provide the same light level as a traditional 45-watt incandescent solution, saving 93% of the energy consumption. In addition to the energy savings, LED lamps do not use hazardous materials, compared to CFLs, which have a small quantity of mercury inside. AC-DC LED drivers must meet new market requirements. First of all, accuracy. Dedicated LED drivers operating from the AC mains must ensure a highly accurate constant output current to provide a high level of light quality and avoid flickering. The latest achievements in solid-state lighting enable this technology as one of the best light sources. New LEDs and diffusers have led to very good light spectrums and diffusion, with a color rendering index greater than 90. Repetitive on-off cycles do not affect LED lifetimes. Time to turn on is almost zero. Heat emitted is less than 4% of traditional sources. As we have seen, HVLED primary side regulation maintains the accurate constant LED current that is needed to ensure consistent light output, avoiding further circuitry. The highly efficient quasi-resonant or QR operating mode boosts energy savings with the reduction of both conduction and switching losses, and working at variable frequency significantly reduces the EMI filtering required, saving space and costs. Finally, the HVLED reduces component count, so very compact, ultra-thin applications can be implemented. The reduced component count also contributes to an increased lifetime for the application. Robustness and compactness are also enhanced due to the elimination of the optocoupler on the secondary side, thus significantly increasing the mean time between failure of the lamp. The HVLED works safely in short circuit, thanks to a self-supply feature that maintains the accuracy of the output current. In the case of an open load, the output voltage is limited and burst mode is invoked, ensuring improved energy efficiency. ST's new HVLED features all primary side regulation, guaranteeing the constant LED current that is needed to ensure consistent light output, without requiring the current sensing components and optocoupler used in conventional secondary side regulation. Where the application needs a controlled constant output voltage, the HVLED is able to generate a very precise voltage level without any component at the isolated side, or PSR. The elimination of these components decreases the cost and size of the LED driving circuitry and saves current sensing losses, improving overall efficiency. The HVLED integrates in a single package the PSR controller with the high-voltage startup for efficient power-on and a robust 800-volt power MOSFET. The highly efficient quasi-resonant or QR operating mode further boosts energy savings for LED lighting and significantly reduces the EMI filtering required, saving space and costs. The HVLED807PF and HVLED815PF feature a new high power factor capability that greatly benefits applications. By shaping the input current in accordance with the input voltage, the HVLED reduces the reactive power being supplied by the utility. Reducing the reactive power supplied by the utility results in a cost reduction to electrical bills, since the apparent power is also reduced. In addition to the high power factor, applications designed with the HVLED feature a very low total harmonic distortion. This also limits the overall power consumption as well as electromagnetic interference to further ensure correct operation and a longer life for the equipment. The HVLED series is housed in the SO16N narrow package. To reduce design time and costs, several reference schematics and evaluation boards for European range, US range, and universal range are made available through ST. You can find other promotional material and order your samples online.